Number 46, solve the linear system. When I look at this linear system, I see that we have a positive 1y and a negative 1y. Those are opposites, so they will cancel out. So I'm going to go ahead and cancel those two. Then using linear combinations, I just combine the 4x and the x, and I get 5x. And the 2 plus negative 17 gives me a negative 15, because when you add opposites you subtract and give it the sign of the larger absolute value. Then you're going to divide both sides by positive 5, and negative 15 divided by positive 5 gives you negative 3. So our x value of our solution is x equals negative 3. We can find the y value by choosing either one of the equations and replacing x with negative 3 and solving for y. So I'm going to go ahead and put it in the bottom equation because that's the simpler of the two equations, since it has just ones as the coefficients on the variables. So it's going to be negative 3 minus y equals negative 17. So I'm going to bring the 3 over to the right side. And when you bring it over to the right side, it was negative over here, so bring it over as addition. Then you're left with negative y equals negative 17 plus 3. You want to add those, or excuse me, subtract, because the signs are different. Give it the sign of the larger absolute value. So I get negative y equals negative 14. To get rid of that negative in front of the y, because we have to do that, divide both sides by negative 1, and you get y equals positive 14. So our x value for our solution is negative 3, and our y value is 14. And you want to take a minute to check it. So checking it in the simpler equation, negative 3 minus 14 becomes negative 17. It checks in the first one. Negative 3 times 4 is negative 12. Negative 12 plus positive 14 gives us 2. It checks out in the top equation. So the answer is negative 3, positive 14.